As would be expected, it is a tough life living next to the sun, but somebody's gotta do it. The closest planet to the sun, Mercury, is truly inhospitable. It is a world of temperature extremes. It is lifeless and desolate. It's a planet that's part furnace, part freezer. The smallest and fastest planet, Mercury, is the closest planet to the sun, as already observed. On average, Mercury can be the closest planet to the Earth, but not only the Earth. Sometimes it is the closest planet to each of the other planets in the solar system. What is interesting to note is that there are two moons in the solar system, Ganymede and Titan, which are larger than the planet Mercury. Because of its movement across the sky faster than any other planet, the Romans named the planet after the swift-footed Roman messenger god, Mercury, also known in Latin as Mercurius, which they equated with the Greek god Hermes. Mercury is located approximately at a distance of 58 million kilometers from the Sun. But when moving in orbit, the distance sometimes changes to 24 billion kilometers. Most observers of the planet Mercury see it as having a pinkish hue. However, the planet itself is actually dark gray, but the pink color shines for the same reason that we see on a setting sun, which turns from yellow to that of a memorable shade of red. Because the light bouncing off Mercury must travel through more layers of Earth's atmosphere to reach our eyes, this eventually makes the light reflected off Mercury's surface appear as a tinted pink. Its sky is as black as night, a very dark night. Mercury is one of the two planets not to have a moon, the other one being Venus. Mercury is the oldest surface of all planets. Mercury is one planet that has a dense metal core. This metal core has a high iron content more than any other planet in the solar system. Many astronomers believe that Mercury might be the core of what was once a much larger planet. It seems like a huge ball of iron covered by a thin layer was once in this huge planet, but it left, leaving just Mercury. Just because Mercury is slightly less dense than Earth, one might conclude that Mercury has a lower percentage of iron, a common heavy element, than does our planet. In fact, Messenger revealed that Mercury's surface is a low iron content. While this is true, it's important to note that in terms of the percentage of its total mass, that is iron, Mercury is in fact the richest iron planet in the solar system. While Earth's greater mass pressing inward and thereby compressing our planet's inner parts makes it denser than Mercury, in percentage terms it has lesser iron than Mercury. In fact, it is suspected that Mercury's core is 80% iron nickel. This compared to Earth's, which is only 32%. The planet Mercury is small, but it's a small, tortured world, roasted dry by the unflinching glare of the sun. It has endured for billions of years. This is not helped by its incredibly thin atmosphere and weak magnetic field, which leaves it virtually unprotected from countless impacts and a continuous bath of deadly solar radiation, despite it having a surface nearly as dark as coal. There are too many impact craters. If it was a human being, you would think it had a bad case of chicken pox all over it. Impact craters have also been seen on Earth, and one famous one is the one found in Arizona. You can also equate the craters to a pothole-filled road in a third world country. These many craters shine as a graveyard of past cosmic battles. Nature at war with nature once upon a time. There is a huge possibility that during the final stages of planet formation, maybe, just maybe, Mercury was struck by a large planetesimal. This was almost like when the Earth was struck by a mass-sized body that led to the formation of our Moon. Mercury has plains, mountains, and plateaus. It also has ledges, the height of which can reach up to 3 kilometers. All these irregularities are associated with fracture of the crust, which might have been due to rapid temperature changes, rapid cooling, and subsequent warming, among many other things. Most likely, this happened during the formation of the planet. The most breathtaking feature discovered by Marina 10 is a very huge circular region called Calories Basin. The name of this feature derives from calories, a Latin word for heat, and in fact, this feature is the closest part of Mercury to the Sun at the planet's perihelion, which means the closest approach to the Sun. Calories Basin measures around 1,550 kilometers in diameter. The Calories Basin is one of the biggest impacts ever on Mercury. Whatever created this crater was extremely powerful, powerful enough to almost destroy the planet. Whether it was a comet, an asteroid, nobody really knows, but it left a huge impact on the surface. The opposite side of the planet to the Calories Basin is evidence of the impact that must have cut through like a hot knife on butter, creating shockwaves on the planet. Calories Basin is surrounded by a ring 2 kilometers high of mountains. It is almost at the border that separates day from night. And inside the Calories Basin is a spider-shaped appearance close to the center. It has several legs, which makes it look like a spider, though while a spider has only 8 legs. This formation has hundreds of legs-like features. No one knows what caused this feature. There are also many other craters besides the Calories Basin. These craters are named after famous artists, musicians, and authors worldwide. These people include John Lennon of the Beatles, James Francis Howe, an Australian photographer, American author Howard Philippa Lovecraft, Russian painter Nicholas Roerich, Africanus Horton, a Sierra Leone writer, Tarsila do Amaral, a Brazilian artist, Honore de Balzac, a French writer, Ludwig van Beethoven, a German composer, the Brown Sisters, Lord Byron, Michelangelo, the Italian painter, Anton Chekhov, a Russian writer, Charles Dickens, English novelist, Walt Disney, American animator, Uzo Eguno, a Nigerian artist, Duke Ellington, an American musician, Benny Nwonu, a Nigerian painter, Fyodor Dostoevsky, a Russian novelist who was thought to be eccentric, Oluwado Ekuno, a Benin writer, William Faulkner, American author, Nikolai Gogol, Russian playwright, Nadim Godman, South African writer, Ernest Hemingway, American writer, Homer, a Greek poet, Victor Hugo, a French writer, Vincent Coffey, a Ghanaian sculptor, Mark Twain, American novelist, John Milton, an English poet, Vladimir Nabokov, a Russian writer, Pablo Picasso, a Spanish painter, Edgar Allan Poe, an American poet, Alexander Pushkin, a Russian poet, William Shakespeare, an English writer, Percy Bysshe Shelley, an English poet. Volcanoes may also have been very prominent on this planet. The closest planet to the Sun is only about as wide as Africa. 18 Mercuries would fit into the Earth. The planet does not have an atmosphere, just like it is on all the other planets. But we will discuss this issue later. There is no water present on this dangerous planet either. Mercury's mass is just about 5.5% that of the Earth. Like on our moon here on Earth, the force of gravity is too weak on Mercury to hold a permanent atmosphere. However, there are traces of 7 different gases like hydrogen, helium, sodium, calcium, magnesium, potassium, and oxygen that have been detected around it. All of these gases drift into space easily because of the lack of an atmosphere and a weak gravity. But, however, these are continually replenished in the same atmosphere from their respective sources. planets, except Venus and Mercury, have natural satellites, often called moons. But despite not having a moon of its own, Mercury has more in common with the moon that shines on Earth. One's first impressions of the planet Mercury evoke a lunar landscape, and indeed, there are several similarities to our moon. Craters in the moon's islets are densely packed, and this is thus the same as some of the craters on Mercury. This has led some of the astronauts to conclude that most of the craters on both Mercury and the Moon were produced by impacts in the first 800 years after these bodies condensed from the solar nebula. And true to that, the impact craters on both worlds, the Moon and Mercury, have striking similar features. These features include ejecta blankets and central packs. Almost the entire surface of Mercury, like the Moon, is covered with craters, and this is akin to our lunar structure that one can be prone to think this could be Siamese twins. Most of these craters were formed in a collision with meteorites. Mercury had many lava flows which welled up from the molten interior to some flooding low-lying areas. The volcanoes on Mercury might have happened towards the end of the heavy bombardment. These volcanoes might have happened between 3.1 and 3.8 billion years after this bombardment. Mercury and the Moon both lack an atmosphere, and thus there is no erosion by wind or water, nor do they have plate tectonics. Indeed, this has resulted in craters formed by impacts of asteroids billions of years ago, remaining visible almost forever. The planet Mercury and the Earth's moon are so small, extremely small, and both have so little gravity that they have not even been able to retain an atmosphere, as already pointed. Thus, heavier gases such as nitrogen, oxygen, and water easily escape them. For the longest of years, it was presumed that Mercury was synchronously tidally locked with the Sun. Mercury, it was thought, was rotating once for each orbit and always keeping the same face directed towards the Sun, a situation similar to that of the Moon, whose same side is always facing the Earth. The Sun's gravity has caused part of Mercury's erratic movement, and this erratic movement in turn prevented it from having a synchronous orbit like the Moon and gave it the famous 3.2 spin orbit coupling. Mercury rotates 59 times more slowly than the Earth for a day to change to the next. That slower rotation and the lower volume of molten iron inside Mercury as compared to that of the planet Earth is the reason why Mercury's magnetic field is extremely weak. Suppose one was to set up a camera at one high location on Mercury to make a stop motion video. One would first see the sun start to rise in the east and then suddenly stop high in the sky. Then after that it would move back towards the east. It would then suddenly stop again and eventually it would resume its journey towards the west. What a crazy movement. The speed of rotation of the planet Mercury depends on the position of the planet towards the Sun in the position known as aphelion, that is, the point of the planet's orbit or of another celestial body like the Earth, for instance, which would imply it's most distant from the Sun. Mercury moves at a speed of about 38 kilometers per second. And at the point of the orbit, when it is closest to the Sun, its speed is 56 kilometers per second. Thus, the average speed of Mercury is about 48 kilometers per second. In the same vein, Mercury, which orbits the Sun at an average distance of 57,909,200 kilometers, has a period of revolution amounting to 87.9686 days, thereby giving the highest average speed in orbit of 172,248 kilometers per hour. While we have noted that Mercury has an orbital speed of 48 kilometers per second, which is 30 miles per second, whereas Earth's orbital speed is 30 kilometers per second, which is 19 miles per second. In other words, as we sit here watching this video, know that we are actually moving at 30 kilometers per second here on Earth, meaning in a second we cover a distance like that from Bindura to Glendale. And as also pointed out about the speed increasing near the Sun, in fact, twice during Mercury's orbit, it gets so close to the Sun and speeds so much that the Sun seems to go backwards in the sky. You know that feeling that you have if you are in a fast car, seeing trees as if they are going backwards? So as we have noted, if one was on Mercury, one would see the sunrise, stop, go back the direction it came from, stop, go back, and set where it would have come from. This sequence happens around 16 times, resulting in 2 to 3 weeks of the sun appearing stationary. The places receiving the sun in that period would thus be extremely hot. We thus have, as a result, a day that lasts 3 months before sunlight finally sets, a summer that lasts almost forever. This, indeed, is a place of wonders, a place of enigmas. But what exactly will be taking place? Mercury's axis is almost perpendicular to the plane of the orbit and is only 7 degrees, so there is no change of seasons for the longest of times. Mercury moves around the Sun faster than any other planet, making its year the equivalent of 88 Earth days. While a day on Mercury, the interval between one sunrise and the next, lasts 176 Earth days. 1 year on Mercury is thus only 88 days or so. Mercury rotates very slowly, but even in that slowness, it revolves around the Sun in slightly less than those 88 days. 1 year on Mercury thus consists of less than 2 days on Mercury. So day and night on Mercury are almost equal to the year of the planet because they last 88 days. Thus, one of the hemispheres of Mercury is for a long time facing the Sun due to its slow rotation. Therefore, the change of day and night occur much less frequently than on other planets of the solar system, and indeed is almost not noticeable. Due to the aforementioned Mercury's 3.2 spin orbit resonance, a solar day in Mercury, that is, the length between two meridian transits of the Sun, lasts about 176 days here on Earth. A sidereal day, which is the period of rotation, lasts about 58.7 Earth days. Looking at it another way, on Mercury, a day, which is the time it takes for it to spin round once, is 59 Earth days. Its year, which is the time it takes to orbit the Sun, is 88 days. That means there are fewer than 2 days in a year. So Mercury takes 59 days to make a rotation, and only 88 days to cycle the Sun. In other words, a day on Mercury from sunrise to sunset lasts about 6 Earth months. So that is why we say, in short, a day on the planet Mercury is twice as long as its year. A day on Mercury lasts longer than its year. The planet feels the full force of the sun's heat during the day, naturally being the closest planet to the Sun. This is bound to happen, but with only the barest of atmospheres, it also experiences freezing cold nights. But back to Mercury's atmosphere in comparison with the Earth. The Earth's thick atmosphere stores heat. This helps explain why it stays warm on cloudy days and at night. That being said, nevertheless, the Earth continually loses heat into space, but not at the same rate as the weak atmosphere that we find at Mercury. And because of the Earth's rapid daily rotation, whatever heat it loses is quickly replaced by the Sun during daylight hours. So the average temperature change between day and night on Earth is only a few degrees Celsius in most places. The temperatures on the surface of Mercury exceed 430 degrees Celsius during the day, and at night plummets to minus 180 degrees Celsius. Mercury has the largest daily variations in surface temperatures. So Mercury's extremely slow rotation and minimal atmosphere therefore cause the difference in temperature between day and night to be far greater than anywhere else, including here on Earth. At noon on Mercury, the surface temperature is highest. At the terminator, that is, at the border, where day meets night, the temperature is about almost half that of the surface. Very low. But on the night side, shortly before sunrise, the temperatures are the lowest and in fact become the coldest temperature on any terrestrial planet. The resulting daily range of temperature is therefore very huge. So even though Mercury is the closest planet to the Sun, temperatures can be very, very low. In fact, the lowest of all planets. Why? Since Mercury has almost no atmosphere, there's nothing to trap heat near the surface. So the dark side of Mercury, which is the side facing away from the sun, is extremely cold. But there are also, near the poles, places where sunlight never penetrates. There is not even the slightest taste of sunshine here. This then results in Mercury being very hot, but not too hot for ice. You can find ice on Mercury. And when we say that it's cold, don't imagine that it's just ordinary cold found here in Africa. No, the closest planet to the sun does indeed have ice, as has been noted, on its surface. That sounds surprising at first glance, and it should be. But the ice is found in permanently shadowed craters, mostly those that never receive any sunlight whatsoever. It is thought that perhaps comets delivered this ice to Mercury in the first place. In fact, NASA's Messenger spacecraft not only found ice at the North Pole, but it also found organics, which are the building blocks for life. So, could there have been life at Mercury once upon a time? Mercury has no atmosphere, and we have repeated this several times. This lack of atmosphere means that nothing protects it from the sun's relentless radiation, and daytime surface temperatures can reach highs of 130 degrees Celsius before plummeting as low as minus 180 degrees Celsius at night. But what about life? We said there might have been blocks of life. Mercury is way too hot and airless for life as we know it. Despite being closest to the Sun, Mercury is not the hottest planet. The hottest planet is Venus at 462 degrees Celsius. Mercury is rated as the most elusive planet and is probably the toughest of the 5 naked eye planets to locate in the night sky. This is because it moves quickly from night to night, unlike the other 4 planets. Nonetheless, as already noted, the brightest or full-face appearance of Mercury is an essentially impossible time for practical observation. This is because of the extreme proximity of the Sun to Mercury. Mercury is best observed at the first and last quarter, although there are phases of lesser brightness. The planet Mercury's proximity to the Sun makes it difficult to see, since the Sun's light washes away Mercury's feeble light, and this makes it invisible to the naked eye during most of the day. The only times you can actually find Mercury easily are when it appears furthest from the Sun. This period is termed by the astronauts as the greatest elongation of the planet, and this is when the Sun is still below the horizon. Sometimes you can catch Mercury just after sunset, and at other times just before sunrise. In very few times, the planet Mercury sometimes appears as one of the brightest objects in our sky, ironically due to that same proximity to the Sun. We can see it from Earth only for a few hours before sunrise or a few hours after sunset, because its angle from the Sun, which is its elongation, is always less than 20 degrees. Mercury can, like several other planets and the brightest stars, be seen during a total solar eclipse. Like the Moon and Venus, Mercury exhibits phases as seen from Earth. These phases have a new at inferior conjunction and full at superior conjunction. The planet is rendered invisible from Earth on both of these occasions because of its being obscured by the Sun, except its new phase during a transit. Mercury is thus technically brightest as seen from Earth when it is at a full phase, a period we are familiar with from observing the Moon. Although Mercury is furthest from Earth when it is at this full phase, the greater illuminated area that is easily seen and the opposition brightness surge more than clearly compensates for the distance Mercury is from the Earth. This makes it easier to see from here. Reaching Mercury from Earth poses significant technical challenges because it orbits so much closer to the Sun than Earth. Because Mercury is so close to the Sun, the world-famous telescope, Hubble, can't look at it. This is because the solar light overwhelms Hubble and damages its optics and electronics. The first telescopic observations of Mercury were made by Galileo Galilei in the early 17th century. Hi there, I'm the world-famous Galileo Galilei, the first one to observe the planet Mercury using my telescope. In his observations, he saw phases when he looked at Venus, but his telescope was not powerful enough to see the phases of Mercury, so he could not be certain about its movements because of his weak telescope. In the year 1631, another observer, Pierre Gassendi,
Bonjour, I'm Pierre Gassendi,
made the first remarkable telescopic observation of the transit of a planet across the Sun when he saw a transit of Mercury. This had been predicted by Johannes Kepler years before.
Ça va? I'm Giovanni Zuppi. Ciao.
In the year 1639, Giovanni Zuppi used his telescope to make yet another discovery. He discovered that the planet Mercury had orbital phases similar to that of the planet Venus and the Moon. These observations demonstrated conclusively that the planet Mercury did indeed orbit around the Sun like all the other planets discovered before it. But most of the basic knowledge of Mercury's geology had been mostly found through the 1975 Marina 10 flyby and terrestrial observations. Marina 10 was the first machine to be sent to Mercury in the 70s. It was the first to provide brilliant pictures about Mercury as well as great information. Though Mercury is the least understood of the terrestrial planets, this mission opened up a lot of information about it. Sadly, on March 24, 1975, just 8 days before its mission was to be closed, Marina 10 ran out of fuel. This became its abrupt end, since its orbit could no longer be accurately controlled. The mission controllers instructed the probe to shut down because it was no longer under their instructions. However, Marina 10 is thought to be orbiting the Sun still, passing close to Mercury every few months, but with not much notice being given to it.
In the year 2000, high-resolution lucky imaging observations were conducted by the Mount Wilson Observatory 1.5-meter Helen telescope. This provided the first views that resolved surface features on the parts of Mercury that were not imaged in the Mariner 10 mission. It became clearer what Mercury's surface exactly looked like. In addition, most of the planet has been recently mapped by the Arecibo radio telescope with 5-kilometer resolution, including polar deposits and shadowed craters of what may be water ice. A second NASA mission to Mercury was aptly named MESSENGER, standing for Mercury Surface Space Environment Geochemistry and Ranging. This mission was launched on August 3, 2004. On its journey, it made a flyby of Earth in August 2005 and passed near Venus in October 2006 as well as June 2007 as it positioned itself on the best trajectory to reach an orbit around Mercury. It eventually made the first flyby of Mercury on January 14, 2008. It had a second one on October 6, 2008, and a third one on September 29, 2009. Its final maneuver was done on April 24, 2015. However, unlike Mariner 10 before it, MESSENGER crashed into Mercury's surface on April 30, 2015, on a Saturday around 1526. The crash impact left a crater estimated to be 16 meters in diameter. October 2018, the Bepi-Colombo mission was launched. This is currently traveling in space towards Mercury, which it is expected to reach by 2025. It is expected to orbit the planet so as to solve several unsolved mysteries about the planet Mercury. It is also expected that it might reveal answers to questions like how planetary systems are formed. Several simulations have been done to forecast Mercury's future. The simulations have shown that the eccentricism of Mercury will make it interact closely with the biggest planet on our solar system, Jupiter. This will cause Mercury to increase its eccentricity. There is thus a 1% chance that the planet may collide with Venus within the next 5 billion years because of this. There are also chances that Jupiter's gravity will eventually either push Mercury out of the solar system or send it crashing into the sun.